Hello friends, in this video we are going to discuss the previous year GATE question number 47. This question is from GATE 2007 examination. So let us read the question. In the circuit of adjacent figure, the diode connects the AC source to a pure inductance. So diode is connecting AC source to the pure inductance. Okay, the diode conducts for, and they have given the four options. Okay, so if you check here, we are having the purely inductive load. As we have already discussed this type of question in the previous questions. Okay, so if the load is purely inductive, okay, pure inductance or pure inductive load. Okay, so yes, what the time taken by the inductor, time taken by inductor to release the energy, is always equals to time taken time taken by inductor to store energy. Okay, so this type of equation we will be having. Okay, so here if you check, we are having the diode rectifier. Okay, so in this case, if you draw the waveform of the I0, yes, when Vs is positive, that is from omega t is equal to 0 to pi. Okay, the diode will be in the forward bias mode. Okay, so Vs is positive, diode will be in the conduction mode. Current will be flowing from source towards the load, right? So I0 will be like this. Okay, inductor go on storing the energy. Okay, so waveform for the inductor current I0, it will be like this. It is from 0 to pi. After pi, what will happen? The supply voltage polarity is reversed. There is a minus plus here. Okay, inductor go on releasing the energy because inductor opposes the sudden change in the current. So the minus here, plus here. It is plus minus. So if you check, inductor is storing the energy for pi radian. So how much time the inductor will take to release the energy? Next again pi radian. So after pi is a pi radian means what? It till 2 pi inductor will release the energy, right? So till 2 pi inductor releases the energy. So here 0 to pi inductor stores the energy, pi to 2 pi inductor releases the energy. But in both the cases, when inductor stores the energy as well as when inductor releases the energy, the diode D will be in the on state. Okay, what is the conduction time of diode? It is a 360 degree, right? It is a 360. Correct option is option D. Okay, so this is about question number 47. In the next video we are going to discuss the question number 48. Thank you.